Hi class, good morning. Welcome to our Week 11 topic in Information Management 2. This week we are going to study about the SQL Advanced Query. The topic objectives. After the discussion, the students are expected to manipulate the structured query language and create the SQL Advanced Query. SQL Advanced Query. The SQL Joins clause is used to combine records from two or more tables in a database. A join is a means for combining fields from two tables by using values common to each. Several operators can be used to join tables such as the equal sign, less than, greater than, not equal, less than or equal, greater than or equal, not equal, between, like, and not. They can all be used to join the tables. However, the most common operator is the equal symbol. Look at these tables. We have the customers table and the orders table. Let us join these two tables using the select statement, such as select CID, FName, age, amount from customers, orders, where customers.id is equal to orders.customer ID. So that SQL will produce the following results as shown in the screen. So the most important and frequently used of the joins is the inner join. So they are also referred to us as the equi-join. The inner join creates the new results table by combining the columns of two tables like table 1 and table 2 based upon the join predicate. The query compares each row of the table 1 and each row of the table 2 to find the all pairs of rows which satisfy the join predicate. When the join predicate is satisfied, the column values for each matched pairs of rows of A and B are combined in a result row. Example, we have the following syntax. Select table 1 dot column 1, table 2 dot column 2. The columns pertains to the field name used for table structure. From table 1, inner join table 2 on table 1 dot common field, it can be the primary key or the foreign key, is equal to table 2 dot common field. Considering these two tables of customers and orders, we have the customers, the seed, the F name, the age, the address, and the salary. For orders table, we have the OID, the seed, the D date, and the amount. So we use this query. Select customer.seed, customer.cfname, orders.amount, orders.ddate. From customers, inner join orders on customer seed is equal to orders.seed. So we are joining the two tables, the customers and the order, using the inner join clause. So following or using those two tables that we discussed, this will produce the following results. How about the SQL left join? This returns all the rows from the left table, even if there are no matches in the right table. This means that if the on clause matches the 0 records in the right table, the join will return a row in the results but with a null in each column for the right table. So this means that the left join returns all the values from the left table plus match values from the right table or null in case of no matching join predicate. So for the syntax, we have select table dot column, comma, table 2 dot another column, from table 1 left join table 2 on table 1 dot common field is equal to table 2 dot common field. So given the customers and orders table again, and using the left join, so we have to produce this kind of output. The SQL right join. SQL right join returns all the rows from the right table. So even if there are no matches in the left table, this means that if the on closest matches the 0 records in the left table, the join will still return on a row in the result, but with the null in each column from the left table. This means that a right join returns all the values from the right table plus not matched values from the left table, or null in case of no matching join predicate. So for this syntax, we just replace the inner join and the left join by a right join. So example, select table 1 dot column 1, comma, table 2 dot column 2 from table 1, right join table 2 on table 1 dot common field is equal to table 2 dot common field. Using the two tables of customers and orders, so for application, we have to use the select customers dot CID, comma, customers dot CF name, comma, orders dot amount, comma, orders dot date from customers, right join orders on customers dot CID is equal to orders dot CID. This will produce the output as seen in the screen for the right join. How about the SQL full join? SQL full join combines the results of both left and right outer joins. So the join table will contain all the records from both the tables and fills in nulls for missing matches on either sides. So the syntax for this is select table 1 dot column 1, comma, table 2 dot column 2 from table 1, full join table 2 on table 1 dot common field is equal to table 2 dot common field. Considering the following tables such as customers and orders, we use select customer.seed, customer.cfname, comma, orders.amount, comma, orders.date from customers full join. Orders on customers.seed is equal to orders.seed. That syntax or that SQL will provide or produce the following results. If your database, let's say for example, the workbench, does not support the full join, the MySQL does not support the full join, so then you have to use the union all. This clause will use to combine these two joins as shown below. So select customer.seed, comma, customer.cfname, comma, orders.amount, comma, orders.date. From customers, left join, orders on customers.seed is equal to orders.seed. Union all. Select customers.seed, comma, customers.cfname, comma, orders.amount, comma, orders.date from customers, right join, orders on customers.seed is equal to orders.seed. And that will also produce the same output as the full join. How about the self-join? This is used to join the table to itself as if the table were two tables temporarily renaming at least one table in the SQL statement. So the syntax for this is select a dot column name, comma b dot column name from table 1 A, comma table 1 B. So we just replace table 1 by A and another table 2 for B, where A dot column field is equal to B dot column field. So here we the clause could be in any given expressions based on the requirements. So consider the customer's table. We have the seed, the F name, age, address, and salary. So we use the following structured query language, such as select A dot ID, comma B dot F name, comma A dot salary from customers A, comma customers B, where A dot salary is less than B dot salary. So to display the decimal place used, select A dot seed, comma B dot CF name, comma truncate, open parenthesis, A dot salary, comma 2 to display in two decimal places as salary from customers A, comma customers B, where A dot salary is less than B dot salary. So this will generate this kind of results or output. How about the Cartesian joins or the cross joins? This returns the Cartesian products of the sets of records from two or more joined tables. Thus, it equates to an inner join where the join condition always evaluates to either true or where the join condition is absent from the statement. So the syntax for this is select table 1 dot column 1, comma table 2 dot column 2 from table 1, comma table 2, comma table 3, so forth and so on. So consider we have to use the table orders and table customers as usual. So let us join these two tables using the Cartesian join, such as select customers.seed, comma customers.cf name, comma orders.amount, comma orders.tdate from customers, comma orders. So that is how we use the Cartesian join as follows. So that will produce this kind of result. How about creating view? Database views are created using the create view statements. Views can be created from a single table, multiple tables, or another view. So to create a view, a user must have the appropriate system privilege according to the specific implementations. So the syntax for this is create view, the view name as select column 1, comma column 2 from table name were followed by a condition. So consider we have the customers table, we have the seed, the F name, age, address, and salary. So to create view, we use the SQL advanced queries such as create view customers view as from CF name, comma age from customers. And then we use the select asterisk from customers view that we have created. So it will generate an output of a two column of CF name and age following those records included in the customers table. So those are the lectures for this week for the SQL Advanced Query. We also have the with check option, which is a create view statement option. So the purpose of the with check option is to ensure all the updates or the inserts satisfy the conditions in the view definition. If they do not satisfy the condition, the update or insert returns an error. So the following code was an example of some view customers view with check options. So example, create view customers view as from CF name, age from customers where age is not null with check option. The with check option class is the case that you should deny the entry of the null values in the view age column because the view is defined by data that does not have a null value in the age column. So that's how we check the create view. And to drop a view, the syntax should be drop view followed by the view name. So example, we created a customer's view. If you want to drop that kind of view, so you just type the drop view customer's view, and then we execute the structured query language. For further readings of this week lecture, you may visit the following sites or references. Thank you and good day.